Welcome everybody. In today's lecture, we're going to look at a couple of interesting examples of Pythagoras Triple by using such a formula here. Please recall that this formula we actually derived it from the previous lecture. Please go back to it to see how I got this formula right in the previous lecture. Okay, please look at this example right here. I'm asking you to construct a right angle triangle so that the length of C, which is the hypotenuse, the highest length here, is bigger than 200. So how to do it? If you look at the previous formula up here, to get C bigger than 200, it basically means that I want the following: P squared plus Q squared bigger than 200. So now the only thing for you to do is that you have to choose some values of P and Q so that they satisfy this formula right here. So there's so many examples to give out here. So maybe I just give you one of them here. Maybe let's say you can choose P to be 11 and Q to be 10 here. So in that case, A is going to be 2 times P times Q based on the previous formula, which is the same as 2 times 11 times 10. And then B equals P squared minus Q squared, which is 11 minus 10 squared. And the final number is 11 squared plus 10 squared. So in that case, I hope you can verify that by calculator or by manual calculation that this number must be bigger than 200. So I believe you can do the calculation on your own. This number is going to be 44 here. The next number is going to be 21 here. And the last number is going to be 221. So I hope this example is more or less a little bit interesting to all of you, because I don't think it's extremely easy to find such a Pythagoras triple which satisfies such a formula here very easily, just by randomly picking any integer which is bigger than 200 as the hypotenuse. So please look at the second example. I want you to construct a right angle triangle so that the length B and C, B is the vertical length here, C is the hypotenuse here, these two values as the length are close to each other. So please think about it yourself a little bit. Now I want that B and C are very close in terms of their values, which essentially means that I want P squared minus Q squared and P squared plus Q squared to be more or less the same. So what does it mean? It basically means that I want this fraction P squared minus Q squared over P squared plus Q squared to be more or less close to 1. So now the question is for you to do here. Do you know how to pick the values of P and Q so that such a fraction here is close to 1 in the value? So please think about it a little bit. It's not a very difficult problem, especially because in this case you have all the flexibility to choose any values of P and Q. So that's one way to do it. If P is a very big number and Q is a very small number, then in that case such a fraction is gonna be more or less the same as P squared over P squared, because in that case this Q squared here is going to be very small, which can be negligible in the case that P is very big here. So obviously P squared over P squared is going to be 1, which is something I want here. If you understand this criterion well here, maybe you randomly pick a big P, for example P equals 100, and then maybe Q equals 1. So in that case, you can do the computation yourself for the length ABC here. You should be able to get that the first number for A is 200, the second number is going to be 9999, and the last number is going to be 10,001. So I hope this example is pretty interesting for you, because it essentially means that the hypotenuse is going to be very long and the base length is so short, and these two lengths are almost the same in that sense. So I hope it's going to be pretty interesting for all of you here, and I'm going to stop this video a little bit. And actually there are a lot more interesting examples to construct for the Pythagoras triples. For some of them I'm going to give out maybe something else as extra video later bit or so on. So anyway, I need to stop it right here. Thank you everybody.